Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will start a new chapter in class 9th, Introduction to Euclid's Geometry. Now Euclid was a great mathematician who is also known as father of plane geometry because of his work in the field of geometry. Before Euclid, there were many mathematicians who worked in the field of geometry, right? Geometry is basically made up of two parts, right? Geo and metry. Geo means earth and metry is about measurements. So the earlier mathematicians or people in earlier civilizations used geometry as a tool for measurement of space on earth, right? They used triangles, circles, these kind of plane figures to measure parts of earth, okay? Now Euclid combined all the knowledge before him in the field of geometry and came out with a book, right? Now the book is known as Elements, okay? He published 13 parts of his book and every part is known as a book, okay? So Euclid collected some obvious universal truths and listed these in his book. Now these are obvious universal truths, so they do not require any kind of proof for them, right? They are also known as axioms and postulates, okay? Postulates are generally related to geometry and axioms are related to other parts of mathematics like algebra or arithmetic, etc. Postulates are mainly for geometry, but nowadays axioms and postulates are being used interchangeably, okay? So these are assumed as truth, okay? These are obvious universal truths, so they do not require any kind of proof for them to be true, right? They are assumed to be true, and the assumptions related to geometry are known as postulates, and assumptions related to other parts of mathematics like algebra and arithmetic are known as axioms, okay? So we know that a solid has got, let us say we have got a cuboid, or you look at the room that you are sitting in, okay? This room has got a certain length, a breadth as well as a height. So a solid has got three dimensions, right? Length, breadth, height in this case, okay? A solid has got three dimensions. For example, this cuboid has got three dimensions. Now this part of this solid which divides the space into two parts, right? One is below this surface and one is above this, okay? This is known as surface, okay? This is known as surface. In this particular case, this solid has got 6 surfaces, and if you talk about a surface, you can talk about only two dimensions in this case, length and breadth, right? This surface hasn't got any height in it, right? It has got only two dimensions, length and breadth, right? And the corner of the surface or end of the surface is a line, right? So a line doesn't have any breadth in it. So line has got only one dimension, that is length, right? And end points of the line, end points of this line are known as points. So a point has got no dimensions. It means that it hasn't got a length, it hasn't got a breadth, it hasn't got a height, right? So point is dimensionless. So we started with solids. The solids have got 3 dimensions: surface, which is boundary of the solid, right, which divides a plane. Let us say this is a surface, right. Now this will divide this space into 2 parts. One is above it, another is below it. When I say a surface, in case of geometrical surfaces, now this surface extends to infinity, right, on this side, on every side. Okay, when I am talking about this plane here, it extends infinitely to every side. So it will divide the space between 2 parts. One is above it, one is below it, right. And this surface can be in any orientation. It will always divide the space in 2 parts. If the surface is like this, the one part is on the left of the surface, one part is on the right of this surface. You get the idea, right. So line is the boundary of this surface, okay, or edge of this surface. If you look around in the room you are sitting in, it is the meeting point of 2 surfaces, okay, where the 2 surfaces are meeting. This edge is known as line, okay, and end points of the line are points. Now points haven't got any kind of dimensions, okay, it is dimensionless, okay. Now Euclid compiled these definitions, axioms and postulates in his work known as Elements, right. He proposed, or he gave 23 definitions in his first part of the book. Now out of those 23 definitions, we will discuss certain definitions here. Some definitions: a point is that which has no part. Now when we say that no part, right, now we need to define this term also. What is a part, right? Somebody can say that a part, now Euclid is talking about area in this, or Euclid is talking about length, breadth or height, right. So this part is still undefined and mathematicians agreed to leave it undefined, okay. So this is accepted as it is, that a point is that which has no part. But we know that if you have got a pencil with a sharp tip and you make a dot, or you draw this dot on the sheet of paper, then this is known as point, right. But you cannot draw the point exactly on a piece of paper. However small the point you draw, it will have certain dimensions, right. So it is not practically possible to draw these figures on a piece of paper, but to understand it, it is enough that you have a sharp tip and you make a dot on the sheet of paper, then this is known as a point. Now a point is dimensionless. It hasn't got a length, it hasn't got a breadth, it hasn't got a height. A line is breadthless length. Now this is a line, right, and when we say a line, it means it doesn't have any end, okay. It extends up to infinity on both sides. So to draw a line, we cannot draw a line on a piece of paper or on this board, right, because it has no end. It extends up to infinity on both sides. So what I'll do is I'll draw these arrowheads, okay. By drawing these arrowheads, I am making a statement that this line extends up to infinity on both sides, and this is breadthless. So it hasn't got any other dimensions apart from its length, okay. So it is a breadthless length. And again, as we discussed in the case of a point, in case of a line, you cannot actually draw a line, okay. However small or however sharp the tip of your pencil is, you cannot draw something breadthless, right. It will still have certain breadth. So it is not practically possible to draw it, but to understand it, we can draw this line here and think about it that it hasn't got any kind of breadth, okay. The ends of a line are points. So now when Euclid says line, he means terminated line. Terminated line, by terminated line I mean the line whose initial point and end point or whose extremes are fixed. Okay. So, in this case this is terminated line. Now, we call it line segment also, line segment, right. This is line segment. Ends of this line or line segment are points. So, this is a point here and this is a point. Okay. A straight line is a line which lies evenly with the points on itself. Now, if you look at this line here, it is just a collection of points, right. So, if we have got points, it is just a collection of points. When I say a collection of points, I mean there are infinite points that lie on a line. Okay. Now, this is one thing. A circle or an arc is also a collection of points, right. But a straight line is a collection of points where it lies evenly with the points on itself, right. So, it lies evenly with points on itself. Otherwise, collection of points can be like this also, but this is not a straight line, right, because it does not lie evenly with the points on it. Okay. So, it should be symmetrical or it should be same everywhere with respect to a point. All right. A surface is that which has length and breadth only. So, yes, we know that you can look at the surface of the piece of paper you are writing it on. The surface is that which has length and breadth only. So, it has got certain length, it has got certain breadth, but it has not got the third dimension, that is height or thickness, right. So, this is a surface and a surface divides the space. Now, when I am drawing this surface on this board here, I have given it a boundary, right, a certain length and a certain breadth. But when you look at the space around you and if you think about a surface geometrically, right, think about a surface, then this surface is extendable or this surface is unlimited, it is unbounded, it extends up to infinity on all sides. So, this surface will divide the space between two parts, right. The edges of a surface are lines. If we have defined a certain surface, for example, in this case, the edges, that is these edges are lines. Okay. And I have darkened it, but we cannot really darken it, because if I darken it, it will get certain breadth. This is like this. This is the edge of surface and it is a line. Okay. Now, a plane surface is a surface which lies evenly with the straight lines on it. So, a plane surface, there may be surface, let us say you have got a sphere, right. The outer part of the sphere is also known as a surface, right. Now, the lines are not evenly placed or the surface is not lying evenly with the lines on it. Okay. But in case of a plane surface, for example, let us say this is a plane surface, it is lying evenly with the lines lying on it. It is same all around for the lines lying on it. The other example that you can think of is a sphere, right. The sphere has got a surface, but it is not a plane surface, right. But if you can divide the surface of sphere into really small part, right, in very small part, so that it looks like a plane surface, then we can say that is a plane surface and it lies evenly with the lines lying on it. Okay. Now, some of Euclid's axioms not in his order are given below. Euclid gave us some axioms, but out of those we are discussing some of the axioms, not in a particular order in which he had written it. Things which are equal to the same thing are equal to one another. This is a very simple statement, right? It is accepted as it is an obvious universal truth once again, right? Now, to understand it more, things which are equal to same thing are equal to one another. Let us say x is equal to 3 and y is equal to 3. So, if x is equal to 3 and y is also equal to same thing, then they are also equal to each other. Then it means x is equal to y. If x is equal to 3 and y is equal to 3, it will imply that x is equal to y as per the first axiom here. Okay, that the things which are equal to the same thing are equal to one another. If equals are added to equals, then the wholes are equal. It means, let us say you have got x is equal to y, right, and 3 is equal to 3. Okay, this is what you have got. Then x plus 3 will be equal to y plus 3. This is the meaning of this second axiom here, that if equals are added to equals, now these are equals and these are equals, and these equals are added to these equals, so the wholes or the result, the end result will be equals. Okay. If equals are subtracted from equals, now I will start with this statement here. If x is equal to y and 3 is equal to 3, then x minus 3 will be equal to y minus 3 also, right? We will write then x minus 3 is equal to y minus 3. So, equals are subtracted from equals, right, and the remainders, that is x minus 3 and y minus 3 are equal. All right. If x is equal to y and 3 is equal to 3, then we can say that x minus 3 will be equal to y minus 3. Okay. Things which coincide with one another are equal to one another. It means, for example, we have got, let us say, these two line segments. Okay. If let us name these line segments AB and CD. If I pick CD and place it on AB, it will superimpose it completely, or it will overlap it completely, right, or it will hide it completely, you can say, right, and vice versa is also true. If I pick AB and put it on CD, it will completely lie on CD. That means it will superimpose CD, or it will completely overlap CD, leaving nothing outside, right. So, if these things coincide with one another, then they are equal to each other. This is what it means. This is true in case of other figures also. Let us say we have got two circles. Okay. If I pick this circle and put it on this one, and it completely overlaps it, and vice versa, this completely overlaps this circle. That means if I pick this circle and put it on this, the boundaries completely overlap each other. Boundaries lie on each other exactly. Then that means these are equal. Okay. In geometry, we will say these are congruent. Okay. The word congruent is used for equality in case of geometry. The whole is greater than the part. It is pretty obvious. Let us say we have got a circle, right, and you divide the circle into sectors. Let us say this is my minor sector. Now, this sector is smaller than the complete circle, or we can say the circle is greater than the sector in terms of area, you can say, right. So, whole is greater than its part. Okay. So, if I say 5 is equal to 2 plus 3. I have divided 5, which is whole, or the entire thing that I have with me right now, I have divided into two parts, 2 plus 3. Okay. Now, this is a part and this is another part. So, this whole 5 is greater than 2, 5 is also greater than 3. So, whole is greater than part. Things which are double of the same things are equal to one another. Let us say we have got 3 equals 3, right. Now, if double of 3 is taken, it is 6, and double of this 3 will also be 6, and they are also equal, right. Or in other ways, you can say that if x is equal to y, right. Now, these are equal, okay. So, these are same things, x is equal to y. When I say same things, when I am comparing two quantities, I cannot compare a line with a rectangle, okay. So, when I am saying these are equal, I mean two areas are equal, let us say two rectangular areas are equal. That way, a line cannot be equal to a rectangle, or for example, a triangle may have equal area of certain square, right, but I cannot say that these are equal, okay. I can say area of that triangle is equal to area of that square, but these two figures are not equal. So, these are same things, x is equal to y, then 2x will be equal to 2y, things which are double of same things, okay. If let us say, to further explain it, if let us say I have got a which is 2x, double of x, and b which is double of y, right. Now, if x is equal to y, then a is equal to b, because these are just doubles of x and y, right. So, you can multiply both sides and see that 2x is equal to 2y. Similarly, we can say things which are halves of same things are equal to one another. Let us take the same example. If x is equal to y and there is a which is half of x and b which is half of y, then we can say a is equal to b, because these are halves of equals, okay. So, a is equal to b. Euclid's 5 postulates. Now, these are certain postulates which were given by Euclid, and these are also assumed to be true without any proof, okay. A straight line may be drawn from any one point to any other point. Let us say you have got a point, let us say it is A, okay, and you take any point, any other point in the space, a straight line can be drawn from this point A to any other point that you take, right. A straight line can be drawn from this point to any other point, right. This is the meaning of this postulate, and this postulate tells us some more things. With the progress of time, we saw that if there is a point, there are infinite lines that can pass through a point, okay. But if there are 2 points fixed, there is only one line that can pass through these 2 points. There is a unique line, there is this unique line which can pass through these 2 points, okay. So, if you have got a point, you can draw infinite number of lines passing through it, right. And similarly, you can say if you have got a point, you can draw line to any other point that is given from this point, okay. A terminated line can be produced indefinitely. So, if you have got, let us say, a terminated line with fixed ends, let us say these ends are fixed, A and B, okay. Now, this can be produced indefinitely, which means I can produce it on this side and also on this side. Why I have marked these by arrowheads? Because these lines are produced indefinitely. So these are of infinite length which I cannot draw on the paper. So I have used these arrowheads. Okay. A circle can be drawn with any center and any radius. So if you have got a center, right, you can draw a circle with any radius. What is a circle? It is collection of points which are equidistant from a fixed point. Let us say this is the center, which is a fixed point in this case, and this is a collection of points which are r distance away from this point. Or you can take any other point and then a collection of points which are, let us say, a distance away from this point, this which is the center. So you can take any point in the space, in two-dimensional space, as center and then draw a circle with any radius. Right? This is not exactly a circle, but you can draw a circle with any point taking a certain radius. Right? All right angles are equal to one another. What is a right angle? A right angle is an angle with measure 90 degree, right, or an angle made between two mutually perpendicular rays. Okay. So the initial point of these two rays is same, right, and these two rays are mutually perpendicular. So this angle is known as right angle and its measure is 90 degrees. So if I take two right angles and name them differently, so I can say angle ABC is 90 degrees, angle PQR is also 90 degrees, hence angle ABC is equal to angle PQR. Things which are same, things which are equal to the same things are equal to one another. Okay. If a straight line falling on two straight line makes the interior angles on the same side of it taken together less than two right angles. What are these angles? Let us say these are two lines. Okay, and there is a third line which is falling on these two straight lines, and these are two interior angles on the same side. Okay. Now if these angles, let us say this is theta, this is alpha, these taken together are less than 180 degrees, two right angles means 180 degrees, then the two straight lines produced indefinitely meet on that side on which sum of the angles is less than two right angles. So if they are produced on this side indefinitely and on this side indefinitely, you can notice that when they are produced on this side, they are converging, they are coming near to each other. So they will meet on this side where the sum of these two angles is less than 180. Now if sum of theta plus alpha is less than 180, obviously sum of this angle and this angle will be greater than 180. So when the lines are produced on this side, they will never meet, right, because their gap is increasing. When they are going on this side, their gap is decreasing. So after a point they will meet each other, right. So they will meet on the side where the sum of these angles is less than 180. Now it gives us another thing, it gives us another result, that if, let us say this is the line, and if sum of these angles theta and alpha is equal to 180 degrees, right, for them to meet at a certain point, the sum of these two angles have to be less than 180. Now if their sum is 180, then they will never meet each other, they will never meet each other. This gives us the definition of parallel lines. So these lines are parallel and these two angles are co-interior angles. So if sum of co-interior angles is 180 degrees, the lines will be parallel. Okay.